Now we have already seen what is optimization. Optimization basically means improvement. Okay, so we are just improving the program. Okay, we are improving the speed of the program and also space. Okay, the space that is required. Okay, now my question is this. Remember, optimization, that is improvement, that is fine, you are basically improving. Okay, tell me this point, is this improvement? Okay, just tell me this point. My question, is this improvement? For example, x equal to 5 plus 8, this statement I am replacing with x equal to 13. Is this improvement? Is this improvement? Just tell me this point. Is this improvement? Yes, this is definitely optimization. I can say this is definitely optimization. This is definitely optimization. My question is this. Is this optimization? Is this optimization? Can I say this is optimization? Can I say this is optimization? Is this optimization? This is not optimization. This is not optimization. This is wrong. This is correct. Optimization should not change. Optimization should not change the meaning, the behavior, the semantics. Optimization simply means improvement. So this you can replace with this. This is improvement. You don't have to add. Okay, this is improvement. There is no problem here. But here there is a problem. Similarly, my question is this. My question is this. Is the following optimization correct? Can I replace this code with this code? Is this optimization correct? Is this optimization correct? Tell me. Yes, this is correct. Yes, this is correct optimization. Okay, see, okay, let me tell you again. Let me tell you. First of all, let me explain. First of all, remember this point. Okay, remember control flow graph. This control flow graph is created for each function. Is created for each function. Okay, so remember, if you have 10 functions, then how many control flow graph will be there? So if you have 10 functions, if you have 10 functions in program, if you have a program in which you have 10 functions, then it means 10 CFGs in program. Okay, is this clear? So the point is very simple. The control flow graph is created for each function. Okay, anyway, let me come back to this point. So, and you know what is a control flow graph? Control flow graph of a function, that is basically I can say nodes. You already know nodes are the basic blocks. Nodes are the basic blocks. You already know. Okay, and edges. What are the edges? Edges are the possible flow, possible control flow. Yes or no? Possible control flow. Correct or not? Yes or no? Possible control flow means the control can go from here to here. For example, here, look at here. This means the control can go from here to here. So this is control flow. This edge means flow, means from here we can go to here. From here we can go to here. From here we can go to here. So edge means control flow. Okay, possible control flow. So node is basic block and edge is basically possible control flow. Is this clear? Now let's come back to this point. Tell me, is this optimization correct? Is this optimization correct? Just tell me this point. Is this optimization correct? This optimization is correct. Let me tell you. This is not in syllabus, but this optimization is correct. Okay. At the compile time, you can do this. Okay. The compiler can do this. Okay. This is called, see this function. This function is unreachable. This is unreachable procedure. This optimization is correct, and this optimization is called unreachable procedure elimination. So if some procedure, if some function is unreachable, then eliminate it. Okay. So this optimization is called name of optimization. This optimization is correct. This optimization is correct. And this is the name of the optimization. Optimization name. This is the name of the optimization. What is the name of the optimization? Unreachable procedure elimination. If some procedure is unreachable, then remove it. Then remove it. Okay. So compiler can do this. This is not in our syllabus. In our syllabus, we only have 3 optimization. Only 3 optimization we have. Okay. We have dead code elimination, common sub expression elimination and constant propagation. We don't have this in our syllabus. In our GATE syllabus, they have mentioned 3 optimization. Okay, only 3 optimization they have mentioned. So this is not in the syllabus. But remember, this is correct optimization. In this optimization, you can notice that from this main program, this function is unreachable. So we can remove it at the compile time. The compiler can do this. Okay, the compiler can do this. So this is called unreachable code, unreachable procedure elimination. Is this optimization correct? Tell me, is this optimization correct? Is it correct optimization? This is not correct optimization because we are calling F21. So, okay, so this is not a correct optimization. This is not a correct optimization. Okay, this is wrong. You can't do this. Okay, you can't do this optimization. Is this correct optimization? Is this optimization correct? Think about it and tell me, is this optimization correct? Yes, this is correct. See, okay, this k square, this is not changing. Okay, this statement is not changing. See, this is not changing, but every time you are computing it, see, this k square, this is not changing in this loop. In this loop, this is not changing. But there is a problem. Every time you are computing this k square, every time you are computing this k square is not changing. K is not changing in this loop. Inside this loop, k is not changing. But what is happening? You are every time, if this loop is running 1000 times, okay, if you are running this 1000 times, then every time you are computing this, every time you are computing this. So what you can do, you can take it out. Just take it out. Just take it out. Okay, this k square you compute only once and you store in the t, so that you don't have to compute again and again. Just think about it. If this code is running 100 times, then 100 times you are doing k square computed. 100 times you are computing k square. 100 times. So what you can do? What you can do? Very simple. Compute it once. Just take it out. Okay, just put it out. Okay, and okay, store this in t. Now this t you can use it here. So this optimization is correct. Yes. And what is the name of the optimization? This is called chord motion. What is chord motion? Okay, this optimization is called chord motion. What it means? It means that you are moving the code outside. See, this code is not changing. This expression is not changing. So you can remove it. You can move it because this expression is not changing. So don't keep it in the loop. Just put it outside the loop. Okay, is this clear to everyone? This optimization is called chord motion. Chord motion means basically if some statement is not changing, okay, find the code which is not changing. Okay, find code in the loop that produces the same value in every iteration. In every iteration, if you are getting the same value, then take it out. This code can be moved out of the loop. Okay, so that you do not have to compute again and again. So this is called chord motion. For example, here, can we do chord motion here? Tell me. Again, you can notice if this is not changing, if the length of the string is not changing, then take it out. If the length, okay, if the length is not changing, then what you can do? You can store string length in a, so that you don't have to call this function again and again. Okay, you don't have to call this function again and again. Is this point clear to everyone? Tell me. Okay, so this is the point. This is the whole point. So this is the chord motion. Chord motion means if something is not changing, then you can take it out. Okay, now is this optimization correct? Tell me. This optimization, is this correct? Just tell me this point. This is not correct because the value of k is changing in the loop. Every time value of k is changing. So this optimization is not correct. In which phase of compiler do we do optimization? Can you tell me? In which phase of the compiler we, okay, like on where do we do optimization? This we have already seen. I told you. Where do we do optimization? Yes, In these stages, we can do optimization. See, in these stages, we can do optimization. On the pass tree, we can do optimization. On the intermediate code, we can do optimization. On the target code, we can do optimization. This optimization is machine dependent. This optimization is machine independent. This is high level optimization. Yes or no? This is the best optimization because this is reusable. You can reuse this. This optimization you can reuse. All these points we have already seen. This optimization is machine dependent. This is machine dependent optimization. This is machine independent. Okay. And this optimization is high level, I can say. This is high level optimization. This is also machine independent, but this is high level. Okay. So the best optimization is here. Here we have best optimization. We can use this optimization. This optimization is reusable. Okay. Now the next point is there is something called liveness analysis, live variable analysis. Yes or no? Liveness analysis. Liveness analysis. Another name is live variable analysis. Live variable analysis. Okay. So can anyone tell me this both are same, but tell me what is the difference between this analysis and dead code elimination? This analysis we are using for dead code elimination. Can anyone tell me dead code elimination? Dead code elimination. What is the difference? Can anyone tell me what is the difference? Is there any difference between these two? Is there any difference between these two? Liveness analysis and dead code elimination. What is the difference? See, let me tell you, this is just analysis. This will give you some information. Remember, this liveness analysis will give you some information. This will tell you which variable is live, which variable is dead. This is analysis. This liveness analysis, this is just analysis. Means this will give you some information. Okay, this liveness analysis gives a certain insight, gives certain information about the code, about properties of the code. Okay. Now, once you have this information, now you can use this information to remove dead code. Okay. This information can be used. Remember, this information can be used for transforming our code to optimized code, to an improved code, to better code. By removing dead code. Is this clear? Is this clear to everyone? Tell me, liveness analysis. This will give you some information. This liveness analysis will say which variable is live, which variable is dead. This will give you certain information. This will not do anything else, no transformation. Now this information, this analysis can be used for transforming our code to better code by removing dead code statements. Yes or no? So you can notice this liveness analysis can be used for dead code elimination. What I can say, finally, I can say that this liveness analysis, these are the analysis. These are the analysis. For example, liveness analysis. For example, liveness analysis. For example, availability expression analysis. Available expression analysis. These are analysis. They don't do anything. They just give you some information. They will give you some information. Okay. This is liveness analysis, available expression analysis. Okay. Some more in our syllabus we don't have. Okay. Now, what are the transformations we can do? Tell me the transformations we can do. Using these analysis, what are the transformations we can do? How can we change our program using, okay, what this will help? Tell me. This will help in dead code elimination. Yes or no? Dead code elimination. Yes or no? This information will help in dead code elimination. So this is transformation. We are transforming our code into another code, dead code elimination. Another use is register allocation. I will tell you, I will explain, don't worry. Another use is register allocation. This is another application. Available expression analysis. This is used in common sub expression elimination. Another use is copy propagation. Okay, copy propagation. Yes or no? So these are the, so you can notice these are the analysis and these are the actual transformations. These are the actual transformations. Now let me tell you very important that optimization simply means do the analysis, then do the transformation. Is this clear? Optimization means do the analysis, based on that analysis, do the transformation. For example, do the liveness analysis and then do the dead code elimination. Is this clear? So the difference between analysis and all these things, are they clear? So optimization simply means analysis plus transformation. So what are the type of analysis? What are the type of analysis? See, if you do analysis on within a single block. So for example, you have a control flow graph. Okay. So let's assume this is control flow graph of main. Okay. And this is control flow graph of F. Okay. So you have this is your control flow graph. This is the control flow graph of main. This is the control flow graph of F. Okay. Let's assume. So this is the entry. This is the entry block. And this is the exit block. And this is the entry block. And this is the exit block. Okay. So now you can notice this is the control flow graph of main. And let us assume something like this. And let's assume here you are calling F. Okay. Maybe you are calling here F. So basically this edge will be there. Correct? Yes or no? Okay. So these are the basic blocks. Okay. So this is basic block B1. This is basic block B2 and so on. Okay, so this is the point. Now let's see. Now you can notice that if you do optimization within a basic block, you don't worry about this. Don't worry about this. Just worry about this. If you do optimization within a basic block, without worrying about other basic block, without worrying about these things, don't worry about these things. If you do optimization within a basic block, that optimization is called local optimization. So within basic block, that is called local optimization, local or peephole optimization. Okay. Another, if you do optimization within a control flow graph, within this, if you do optimization within here, okay, in this area, if you do optimization, or if you do optimization here, then that is called global or intra-procedural analysis. Okay, global or intra-procedural. Next, inter-procedural. What is that? Can anyone tell me? Inter-procedural. What is that? That is whole program. This whole program, this optimization. If you do optimization here, then that is called inter-procedural optimization. In our syllabus, we have local optimization. This is in syllabus. But this is in the syllabus. But we will see some of, okay, we will see some idea of it. We will see some idea. We will see some examples, so that if any question comes, then you can handle it. And this you can very easily skip. Without worry, you can skip. Okay. So this is your local optimization and so on. Okay. Next. Also, there is two type of analysis. One is data flow analysis. Another is control flow analysis. Okay. Can anyone tell me, see the difference in the names? Control flow analysis means where the control is going from one basic block to another. Okay, where the control is going. For example, okay, let me ask you. Okay, control flow analysis will tell you where the control is going. Okay, from one basic block to another, the control is going. How the control is going. Okay, another is data flow analysis. In the data flow analysis, we worry about how the data is flowing, how the data is going from one place to another, one instruction to another, one basic block to another. Okay, so the data flow analysis, see, control flow analysis only worries about the control. So this is your control, yes or no? This is your control flow. Age indicates control flow, yes or no? Age it indicates possible control flow. Correct? Agree or not? So you can see age indicates possible control flow. So okay, any analysis which is based on this control flow, that is your control flow analysis. Okay, and similarly you can notice there is data flow analysis. How data is going, how data is behaving, how data is going from one block, one basic block to another, how data is going from one instruction to another. This is called data flow analysis. Okay, so can anyone tell me, okay, just tell me this point, this this analysis, what is this? This is data flow analysis or control flow analysis? This optimization is based on what? Control flow or data flow? This optimization, this is control flow. Very good, very good. Okay, so this is control flow, this is control flow analysis. Okay, also tell me, is this local optimization, global optimization, or inter procedural? What is this? This is inter procedural, intra procedural. What is this? This is control flow analysis, that is fine. What is this? Local optimization, global optimization, or the inter procedural? This is inter, not intra. See, this is inter procedural. There is a this procedure. There is no control here. This is inter procedural. Are you getting this point? This is inter procedural, means whole program. Inter procedural means whole program. Inter procedural means whole program. So this is inter procedural and analysis, optimization. Okay, now can anyone tell me what is the difference between unreachable code and dead code? Can anyone tell me the difference between dead code comma unreachable code? And is there any difference between dead code and unreachable? Dead code versus unreachable code, is there any difference? No, these are not same. See, remember your TOC. In TOC, is there any state, is there any difference between unreachable state and dead state? In DFA, okay, what is dead state and what is dead state and unreachable state? Is there any difference? Is there any difference between unreachable state and dead state? For example, okay, for example, tell me, tell me here tell me, just tell me this point, what is unreachable state? So you can notice this is unreachable state, this is an unreachable state, and this is dead state. So is this difference clear? Is this difference clear? Unreachable comma dead. So for example, dead code versus unreachable code. See, unreachable code, this is a property of control flow. This is the property of control flow, how the control is flowing. And this is the property of data flow. This is the property of data flow, means whether data is used or not, whether data is used or not, whether data is further used or not, is further used or not. So basically the difference is like this. Okay, let me tell you the difference like this. Dead code means like this. Dead code says that if you have some variable a equal to b plus c, will this value be used somewhere? Will you use it? Will you use it? Is there any use? Is there any use? Unreachable code means what? Unreachable code means what? Will you reach it? Unreachable code means will you reach it? Will you reach? Will you reach here? Will you reach here? Can you reach here? Basically, is it reachable? Can you reach here? Is this different? Is this difference clear to everyone? For example, okay, this is dead code or unreachable code? Tell me here. Okay, tell me. Just tell me, okay, this example, take this example. Is this unreachable code or dead code? This, for this function f, for this function f, this statement, is this unreachable or not? This is reachable, but this is dead. We are not using this value. Can you notice this is dead code? See, this value we are not using. We are not using this value. This statement is dead. You can remove it. This is dead code. You can remove it because we are not using this value z. This assignment we are not using. Okay, tell me. Now this is unreachable. We cannot reach it. See, you will return from here. You will return from here. You will return from here. So now this is unreachable. You will never reach it. Okay. So the difference between dead code and unreachable code, is this clear to everyone? So can you notice dead code is unreachable code, that is property of control flow. This comes in the control flow analysis. This we study in control flow analysis. This we study in control flow analysis. And this we study in dead code analysis. Data flow analysis. This we study in data flow analysis. In our syllabus, what we have? Data flow analysis or control flow analysis? What we have? We only have data flow analysis. We don't have control flow analysis in our syllabus. You can check the syllabus. They have explicitly mentioned the data flow analysis. Okay. Is this clear? Now we will study live variable analysis. For GATE exam only these things are okay important for GATE exam. For GATE exam, for GATE, these are important. Data flow analysis. Okay, this data flow analysis. In this data flow analysis, we have we have something called liveness analysis. We have something called liveness analysis. Okay, we have availability expression analysis. Available expression analysis. Okay, also we have constant propagation. Okay, so constant propagation, these we have in the syllabus. Okay, so only these are important.